Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about Newton's laws and forces. And in this video, I will explain some tricky and challenging questions from Cambridge AS Physics Paper 1. Here is our first question, and this question is about Newton's laws, especially about Newton's second law. So you can read this question first of all by yourself and try to answer this. And then you can come back and you can compare your answer with my answer. So let's try to find out what is given to us for this question. So for this question, the mass of rocket is given here and it is launched from Earth's surface. This is also a very important piece of information. And also the upward force is given to us is here. What we need to find out, we need to find initial acceleration of the rocket. So I have seen this one. Some students, when they read this question, they will recall quickly that F is equal to ma, and then they will say A is equal to F over m, and then they just plug in these values, the upward force, and then they will just divide by the mass and they will write down the final answer, and here they will write down the units, so they will get the final answer. But this is wrong actually. They are missing something. So let's try to find out what is missing. So the best way to answer this type of questions is, first of all, draw free body diagram. So in this case, we can see one force is given that is acting up. That force we can say is F1. Upward force is given, that is here. So this is value of upward force. But also we need to understand, as the rocket has mass, there is also force acting on the rocket due to gravitational field, that is the weight of the rocket that is acting down. So we can say that is F2, and F2 will be equal to mg. Mg, as the m is given, this is value of m, and the g is equal to 9.81 at the surface. So this is very important. Earth's surface, so g you can take 9.81. So this is now, what is the net force now? So if I need to write down the net force, F net, that will be equal to F1 minus F2. So now you can use Newton's second law. So now we can use Newton's second law. So we can say that A is equal to F net, means the resultant force on the rocket divided by its mass. So resultant force in this case is upward force minus weight. So here we can write down weight. So it is multiplied by 9.81, and all we need to divide by mass. So if we do this one, we will get our answer is 1.2 meters per second, and this is our final answer. Here is our second question, and this is kind of typical question from Cambridge paper 1. So let's try to find out what is given to us first of all. For this question, it is given to us that the ground is frictionless and the wall is rough. So we need to understand what's meaning of frictionless. Frictionless ground simply means that there is no friction, and rough wall simply means that there is friction. So the rough wall, we can say rough wall. So this is simply telling us there is friction. So these two things we have to be very clear. Okay, now what we need to find out, we need to find out, show direction of forces P, W, and R acting on the ladder as it slides. So we need to find directions of P, W, and R. So the first thing we need to understand, the weight, for example, weight always acts downwards. So weight always acts down. So this is one. Second, how about normal reaction force? let's say we place this box on the ground, so the normal reaction force on the box will be acting upwards, and this is always at angle of 90 degree to the surface. So this is what we need to understand about normal reaction force. The third force in this case is frictional force. Now let's say we have this block and it is placed on the ground and the ground is rough. If we apply force F on this block to the right, there will be frictional force acting on this block to the left. So this is frictional force acting on the block to the left. So it means friction always opposes the motion. Now let's try to figure out here. Now as you can see here, at this point the force acting is P. Actually this is not right. Actually at this point there are two forces acting. One force is normal reaction force, that is at angle of 90 degree to this surface. So this one is N. And as this ladder has tendency to slide down, there is a frictional force acting on this one, that is upward. So this is frictional force. So direction of P we can find out. So we can first of all combine these two vectors. So this is our normal reaction force. We just change the place of the vector. So and also here is a frictional force. This is frictional force. So we can find the resultant of these two vectors now. So the resultant will be this. So this has to be actual direction of force P acting on the ladder at this point. And normal reaction force is quite straightforward one. It has to be at angle of 90 degree to the surface. So this is the force acting on ladder at this point. So simply this is what we need to understand. So this has to be direction of P. So this has to be direction of P and this has to be direction of R. A is not correct as we have already seen. But if you look at C, C is also not answer because direction of P is wrong and R direction is also wrong. So this is C is not possible answer. Now if we look at D now, direction of R is wrong and direction of P is correct, but this is not also our possible answer. Now if we look at B now, you can see direction of R means the force on the ladder from the ground. This is R, so this is correct, and also you can see direction of P is also correct and direction of W is also correct. So this is our possible correct answer.